Great. Hi, everyone, and welcome to Docker Enterprise Social Distance Learning provided by Mirantis and Stone Door Group. My name is Andrea Alexander with Stone Door Group, and I will be your host for today's event. Today's topic, Docker Tips for Better Security, will show you how to leverage features of Docker Enterprise Edition for corporate security and regulatory compliance. Our presenters are Amber Ernst, Docker Accredited Instructor and Certified Associate at the Stone Door Group, and Bill Mills, Head of Curriculum Development from Mirantis. For those of you not familiar with Stone Door Group, we are a Mirantis Solutions Integrator and professional Docker value-added reseller, specializing in DevOps transformation. We work with companies of all sizes to implement best practices using Docker and Kubernetes. As part of our service offerings, we have two items that may be of interest to those attending today's session. The first is our Docker CE to EE Accelerator Engagement. This service provides the end-to-end solution for migrating your applications to a secure production environment. In our Accelerator Engagement, we take care of upgrading to Docker Enterprise Edition and migrating your applications. We do provide all the licensing needed as well as consulting services to ensure you successfully upgrade to EE and have the necessary controls in place. What we have found is that most of our customers have typically implemented CE, but are limited deploying to production due to security constraints. So this has been a very successful engagement with our clients who struggle with the choices and options that Docker provides. A typical engagement will typically take around 2 to 3 weeks from start to finish. The second item I wanted to bring to your attention is our free 5-day trial of Docker EE. This is available on our website at the link provided on your screen. We will send out this deck following today's event so you have access to these details. And you can find out more about Stone Door Group and our offerings at stonedoorgroup.com. Just a few housekeeping items. If you are experiencing audio issues, you may dial in using the toll-free number provided on the screen. That's 888-788-0099, and our webinar ID is 742-327-577. If you need assistance, please contact a member of the Stone Door Group technical support team at webinar@stonedoorgroup.com. Our team members are standing by ready to assist. During the presentation, we ask that all participants submit questions through Zoom's Q&A feature. You can find this panel on the bottom of your screen where it says Q&A, and just note that this is different from the chat feature. Instructors are going to be collecting and responding to questions submitted through the Q&A panel at the end of the presentation. For those interested, we are recording today's event. We'll be sending out links to all participants for access to the event, recording, and the presentation materials. If you have any questions, we encourage you to reach out to us at letsdothis@stonedoorgroup.com. And thank you all for joining us. Our Docker Enterprise Social Distance Learning Series has been comprised of 4 webinars. This is the 3rd event in our series. We previously learned how to upgrade from Docker CE to EE and improve our Docker administration. Today's event provides helpful tips and recommendations to improve your Docker security. Following today, we will host our final event on May 14th, where we'll cover Kubernetes tips for better productivity, where we're going to provide tips on implementing and administering Kubernetes. We hope you'll be able to join us for this event as well, and we'll send the schedule and registration information to all participants following today's event. As many of you may know, we hold a drawing following each webinar, so I just wanted to provide a quick congratulations to those participants from last week's event who were selected to receive promotional gifts. We've got US winners and international winners, and each of them will receive a Stone Door Group Silly Pint. So congratulations. At this time, I would like to introduce our presenters. I've got Amber Ernst with the Stone Door Group. Amber is a Docker Accredited Instructor and Certified Associate at the Stone Door Group. She is a subject matter expert on both Docker and Kubernetes and teaches all courses in Docker's official training catalog. Also with us is Bill Mills with Mirantis. Bill is the Head of Curriculum Development at Mirantis, where he teaches, develops, and maintains the Docker Enterprise Training Stack. Amber and Bill, thank you for your time today, and I will pass the session over to you.
Welcome and thank you for joining us today. We really appreciate to have you here. So quick refresher on Docker here. It's scalable, easy to maintain, and even easier to get set up. So as many enterprises have allowed their individual developers to install Docker Community Edition and test it as part of a proof of concept or development in labs, they find that they're quite successful with it. And after this resounding success, many developers will run into questions on compliance issues when they want to promote their Docker containers to production. Questions like, where did they get their content? Is it trusted? Are the licenses compliant? How do you encourage your developers' passion for momentum and meet your security team's need for regulatory compliance? How concerned should you be when it comes to securing your Docker content? These are all valid concerns, and of course, they have to be addressed. I'm going to say one of the easiest ways to address them is, of course, with Docker Enterprise. So Enterprise comes with many security features that address regulatory and compliance concerns. So if you have a large organization, a significant number of employees, and a multitude of Docker containers, there's no doubt that you're going to benefit from Docker Enterprise. It has a secure by default ideology. It focuses on 3 critical areas for securing our containers: access, content, and platform. Now, the default configuration and policies provided by Docker Enterprise, they provide a solid foundation for securing your environment and the content that's in it, straight out of the box. However, you can configure these to meet the needs of your organization. So what we're going to do today is focus on some ways to secure your Docker content with Enterprise. And I have this divided into sections on access control, content control, and then covering sensitive information. So first and foremost, let's just go ahead and start with managing access, right? Now there's a quick note I want to make here. To take advantage of the built-in security configurations and policies, you want to make sure you're running the latest version of Docker Enterprise, right? Now, we do have FIPS first listed, and that is Enterprise supports this following cryptographic security function in the engine. It is actually a combination of several Docker default components. So you have your SHA-256 ID hashes for Docker objects, swarm mode, distributed state store, and raft log. This securely stores Docker secrets and Docker configs. We have our swarm mode overlay networks, which is control plane only, swarm mode mutual TLS implementation, and Docker daemon socket TLS binding. Now, the way to enable FIPS mode on our engine is included in the documentation that I have at the end of this slide, okay? The next we have listed though is Seccomp, our secure computing mode. This is a security feature of the Linux kernel, and it is used to restrict the syscalls available to a given process. Now, out of the box, Docker comes with a default Seccomp profile that works exceptionally well for the vast majority of use cases. Now, the next one I have listed down here is AppArmor and SE Linux. These guys are security modules very similar to Seccomp in their use of profiles. And I'll cover those in a second here. So let's start off with just taking a look at Seccomp, right? We've already got it. If you recall, Docker comes with a default profile straight out of the box. So let's switch over to a demo and I will show you guys what this looks like real quick. Okay, so just to show you guys, I've got my environment up that I'm working with, right? And I've already got UCP and DTR running on here, so that's what you're seeing here. But to check if we have Seccomp running, it's a real simple command. We would just grep for our config, our Seccomp configuration, Oh, hold on a second. Give me 2 seconds. Okay. Well, generally this does work. Let me flash over here. Okay. Oh, sorry guys. So we would grep for this, and it's simply going to give us this -yes reply. So let me go ahead though and switch over to our AppArmor SE Linux. Now, I'd mentioned these earlier, right? That the modules are similar to Seccomp in their use of profiles. There we go. So recall here that the security modules, they're similar in their use of profiles. However, the profile languages used by AppArmor and SE Linux are different. So to enable SE Linux, we would be modifying our etc docker daemon.json. And I've got a quick chart here to show you the different types of security and the feature just between these two if you needed to compare them side by side. So for our AppArmor, this is a path name based system. And for SE Linux, it is label based, right? It's associated to int node. For AppArmor, they label and relabel a file bar fs. It's not required. SE Linux, though, it attaches labels to all of the files and processes. Now, if we were to compare both of these on their features, with AppArmor, we would have this based on the principle of least privilege. And the path names are fairly easy to audit and understand. If we're working with SE Linux, it's based on the default deny principle. And not all of those applications are going to preserve their labels. So there's a small downside there. Now, as far as ease of use between the two, they both are fair for advanced users, obviously, but AppArmor is a little friendlier for newer users, and it has more auditable policies if you were going to compare the two in that regard. Okay. So Docker Enterprise, it enhances our role-based access control policies. In fact, hold on, before I even move to that, I really want to get Bill in on this. Bill, what is your experience between Seccomp and working with other types of security in this regard?
Thanks for the intro, Amber. So with this whole suite of features from the Docker engine, so secure computing mode, Linux security modules, as well as root privilege management, that sort of I put under this umbrella of process control for your containers. The idea here is to take away abilities and powers from containerized processes so that in the instance that anybody ever successfully breaks in to one of your containers, you've shrunk the tool set that they have to launch further attacks against your hosts and against the other containers that you're managing. So I mean, containers are famously secure by default, right? Really aggressively isolated, just, you know, without managing any of this stuff hands-on. But we always have to prepare for the eventuality that someone's going to break in to one of our containers at some point. By enforcing the secure computing profiles and these Linux security modules, like I said, we take those tools away. We take away system calls from our potential attackers, from the containers that we're running. With these Linux security modules, I like to really focus on the file system restrictions that Amber pointed out these make available. So really, these serve as a couple of different ways of enforcing mandatory access control on different file system paths in your containers. And so you can really lock down what those containerized processes can do by leveraging these. But there is a big but with all of this, a big cost to all of this. And that is that in order to make those decisions, right, in order to decide what system calls to take away from your containers, to decide what paths become unreadable or unexecutable from within your containers, you have to really understand what that container is meant to do. If you don't understand, don't have a really articulate knowledge of what processes are supposed to run in a container, then you have no idea how to take away system calls from that container. What system calls should you take away? You don't know unless you know what processes you expect to run in those containers. This is why, or one of the reasons why, I push people so hard to design containers to do exactly one thing, to run exactly one process. If you know what process you intend on running in your container, then you can easily answer these questions, right? You can say, well, the ping process or whatever that I want to run in this container uses this list of system calls, so I can take away everything else. It needs this set of accesses to the file system in this container, and I can take away everything else. If you go and try to make Swiss Army knives, containers that run any number of different processes, then you can't answer those questions so easily anymore, right? You have to just allow all system calls and all access to everywhere within the file system of your containers. You can't lock it down as effectively as you can when you have a very specific process or set of processes you want to run in your containers. I'll hand it back to you in just a second here, Amber. There's one other key point that I want everyone to understand here, particularly about system call management with these tools. So when people first come to containers, especially when security-minded people first come to containers, they look at it and say, oh no, all these containerized processes are running as root. It's a disaster. This is totally insecure and what a mess. You got to remember, with root privilege management, system call management, root doesn't really mean the same thing that it might have in traditional times, right? Back in the day, we used to think of root as being root, being the super user that has access to all the system calls, all the powers and privileges of the Linux system. But with this, with these security layers that Docker layers on top of containerized processes, yes, that containerized process is running as root, but that root user doesn't have all the same privileges as a full root user would uncontainerized. So really, this is what mitigates the danger and the risk of running processes as root in containers.
Yes, absolutely. Thank you for that input, Bill. Okay, let's talk about access control in regards to our RBAC policies. So these enhancements, they allow organizations to have a more granular control and flexibility policy modeling. So this helps you to address these questions listed here. So how do I prevent my teams from viewing or interacting with these applications in our infrastructure? How do we enforce this scheduling on certain nodes? And how can I manage these access policies in a clear and understandable manner? So this is a policy-based model. It uses access control lists that are referred to as grants, and they dictate access between users and the cluster resources. Now, real quick here, a grant is a rule that states who can do what actions to which resource. So things like roles, the operations that can be performed by whom. A role is a set of permitted actions in a resource like a volume that's assigned to a user or a team with a grant. Our collections, they're directory-like structures. They contain swarm resources, and they can be created in our UCP by defining directory paths and then having resources moved to them. And then our subjects can be granted a role that defines what operations are permitted in one or more resource sets. So I've already gone through and I've set this up for the sake of time. So let me just go ahead and log in to our system. Okay. It's just going to be one of those days, guys. Give me a second here. There we go. Okay, so this is what you're going to see when you get into your UCP, your dashboard, right? And I'm just going to give you some coverage on what I've got going on with this environment. I currently have 4 replicas of our production website, and I have another running 2 copies of our staging site. So I can actually see these services down in Swarm if I go into it, right? Now, at this point, they're running next to each other, and the only user on the system that can manage these is our admin for the most part. Now, what I've done is I've taken the privilege of going through and already setting up some of these portions of this, our organization. So let me show you guys what this looks like. So within our shared resources and our access control, that's where we're going to be working if we are working with this role-based access control. Now, to create an organization, right here I have my corp. It's quite simple. We would just click create and we would name it, right? If we wanted to create users, it's the same kind of situation. As you can see, I've made Jane and I've made Tom so far. If I wanted to make another user, I would just say, let's say we're going to put Bill in here, right? And we would leave it all in lowercase. I want to make a note of that because otherwise it's going to give us an error. Okay, so we've added another user just like that. That's simple. Now, if we're looking at what their roles are, so let's go over to their roles in Swarm. We can see the roles that we can assign people. And let's take a look at collections though. So with collections, if we want to see what we've got going on, we would click View Children. And we would look in shared. So I have the MyCorp one that I have set up, and additionally, I have some sub-collections that have been assigned to it. So to create a collection, it's very simple. We would click create and name it. To create any sub-collections, we would view the children, and then we would create a collection from that point, right? So I've gone through and I've created production and staging already. Now, if you wanted to grant people access to this, we would go over to grants. We'd go back into Swarm because that's where I'm working, right? And you can see here that I've got some teams that have already been given access, but let's just create a grant. Okay, so we could select it by user or organization. This is how we can get fine-grained with this, right? Say I want to give Bill access to our production collection. And I just wanted to give him view only. Grant created successfully. It's that simple. Now, just so you can get an idea of what this looks like though from a user viewpoint, let's say we log out as an admin and we go ahead and we log back in as one of our users, Tom. Okay, now if we go over to our services, we can see that he's limited in what he can actually see in our system, right? So if we had any services attached to his team, they would be able to see those associated containers and services. Okay, so he can see his access is extremely limited. That's the point. Now, I just want to point out that this can get so detailed when it comes to that, right? There's so much that we can do to give this fine-grained access control in regards to this. And I think Bill probably has some good insight on this as well. In fact, Bill's like the Docker master in my mind.
Thanks, Amber. So the one thing I would really point out is exactly what you just ended with there, Amber, is that there's an enormous amount of detail that you can impose on top of Docker Enterprise for controlling access to the platform. That is powerful, but it is also dangerous. And the number one piece of advice that I give people when designing their RBAC structure is keep it simple. Keep it as simple as you can. Amber, can you go back to your UCP for me? Log in as admin. I want to take people on a little tour here.
Absolutely.
So Amber was pointing out a second ago, the way Swarm manages resources. So I'm talking about containers, services, volumes, all the stuff that Swarm schedules. It groups them together in these things called resource collections, which are these like buckets of objects that you can assign permissions to. Now, if there's any Kubernetes fans in the audience, the closest analogy in Kubernetes would be a kube namespace. And one thing I really like about Kubernetes namespaces compared to Swarm resource collections is that, as you probably know, you cannot nest Kubernetes namespaces. There's no such thing as a namespace inside another namespace, right? That's just not a thing in Kubernetes. And I generally really like that and encourage people to do something the same or similar when creating resource collections, just to keep things simple and easy to understand and easy to audit. Right? When you've got 5 users and 2 apps, well, whatever, right? It's pretty easy. But when you're trying to impose role-based access control over your 50,000 developers with hundreds of line of business applications, it turns into a mess really, really quickly if you aren't very meticulous about keeping your role-based access control rules easy to read. And one technique for that is not nesting your resource collections too deeply. So Amber, if you go to your collections under shared resources there, let's just review what we had here. So Swarm is the default one that this all comes with. That's like the root of your file system. Now, if we go under, I think you were under shared is where your one was. Okay, so here we go. Swarm and shared are like the default ones that come along with UCP. You're going to start creating stuff typically under the shared collection like Amber did here for MyCorp. So let's just drill in there under MyCorp. So we can see that MyCorp has a couple of children, production and staging. Now, that's a very reasonable resource collection structure that Amber has made there. It's only got 2 levels essentially, right? MyCorp and then the 2 teams underneath MyCorp. Now, the thing to understand about this and where the risk, where the complexity comes from is that permissions granted at the root of this resource collection tree trickle down to all the sub-resource collections. So if you give some permissions to MyCorp, everybody in production and everybody in staging is going to get those same privileges applied to them. And the reason that's a problem is that that becomes really hard to read. You'll look at your list of grants and say, oh, I gave this grant to MyCorp. Well, that also implies that you gave those same grants to those child resource collections as well. So you can see there that trickle down mechanism makes things really hard to audit if you have nesting upon nesting upon nesting, like really deep layers of resource collection nesting. So usually how I set this up is a 2-level structure where almost all users only get permissions granted to the leaves of the tree. So like production and staging here, the very like bottom most resource collections that don't have any of their own children. By restricting most of my grants to the bottom of the tree there, that means that I'm not getting that trickle-down effect, or at least I'm getting it as little as possible. The only people that should have grants typically to parent resource collections, so this would be the MyCorp resource collection that contains production and staging here, would be like senior admins, senior like ops and troubleshooting folks that have to have that level of control in order to manage the rest of the RBAC system and take drastic action across all the resources managed by these resource collections. Very few individual contributors really ever need access to those parent resource collections.
Very true. Well put. Okay. Thank you, Bill. So let's go ahead and go forward. Let's see here. There we go. So let's start talking about our content control. Now, our Docker Trusted Registry, if you've been working with Docker before, you're fairly familiar with this, right? Or if you've worked with Enterprise at least. So Docker Trusted Registry enforces this secure by default theme for us, and it has this with 2 features. So we have image signing with our Notary project and image scanning. Now, DTR shares authentication with UCP, and it simplifies setup and provides us a well-built RBAC without any added effort. And Docker Trusted Registry, it stores metadata and layer data in these two separate locations. So our metadata is stored locally in a database that is shared between our replicas, and our layer data is in a configurable location. So let me go ahead and just give you guys a quick tour of this, right? So if I just go over to my Docker Trusted Registry, you're going to see it looks similar in some ways to our UCP, right? We use our UCP credentials to log in, and here we are presented with a list of our repositories. Hold on, let me see if it's gonna make me log back in. Yep. There we go. Okay, so we've got our repositories listed here. And then under this, we have our organizations. So you'll see that my corp that I've got set up has been put into this. And then we have our users, okay? This, you can add new users, you can create new repositories, you can add new organizations. This will be tied to your UCP. Now, there are some automation aspects of the DTR as well. So say as an admin, if we went and we created a new repository, we could grant one of our teams read-write access to this, and then we could do something called a scan on push in this repository. So let's just open up one of these. So if I am opening this guy up, I go down to settings. Here we go. Let's just create a new one, right? I'm going to create one under my corp. And I'm going to just call it, I'm going to call it production again, okay? And if I go into these advanced settings, this is where we can see that we can set this to be pushed automatically. Okay, we can scan these on push. As soon as something is moved, our new image is moved into this, then we're going to have our system automatically scan it for us. Now, there's some more to DTR, but I want to cover a few different aspects first before I show this to you guys. So let's talk about security scanning. So we want to enable security scanning in DTR. It is a wonderful tool that we have available. And I just have a recap of these instructions as to how to do it. So first, we would be logging into our DTR instance as an administrator. We would go to our settings, click on security, and enable our scanning, the scanning toggle. I'll show this to you though. We can set this for scan on push and scan manually, as I was showing you guys just a second ago. So back in our DTR, if we go to system, right, when we're logged in with these credentials, we're presented with this overview. And if we go to our system, we can go over to security and we can enable scanning. Now, something I want to point out about this is that here it is, DTR is downloading a list of these known components with any security problems. And the first time you enable this, and you enable this online syncing, it will take some time because our database is quite large. So by default, our DTR will upgrade this database every night, and we can configure some aspects of this, but this is an every night situation. And the differences with our old version are going to be downloaded. So the large database itself is only downloaded one time. So let's talk about image safety real quick. It's obvious, these few things, right? We want to use images we can trust. We want to require images that are signed. And we want to go over signing images with Docker Content Trust. So I'm going to just break each one of these sections down. So first things first, one of the first rules of image safety is to make sure you trust the images you're using. How do you know they're trustworthy? And the best practice here is to use Docker official images. These are a curated set of Docker repositories hosted on Docker Hub. Some of these will include Alpine, Ubuntu, Python, Golang, Redis, Postgres, anything that's one name, right? Each of these has over 10 million downloads and has a dedicated team that reviews and publishes them. Additionally, we want to ensure that images are signed by our Docker Content Trust. Now, Docker Content Trust gives you the ability to use digital signatures for data sent to and received from remote Docker registries. This prevents our users from working with tagged images unless they contain a signature. Now, something I want you guys to keep in mind here is Content Trust is disabled by default, but to enable it, it's a pretty simple situation. So we would just enable. So let me go ahead and show you guys, though, what this will look like. Hold on. There we go. So with Docker Content Trust, let's head over to, let's go to my manager one, right? Now, to enable this, we can generate a key. It's really simple to do that. Let me show it to you real quick. If we wanted to enable one of these keys, it would simply be a Docker Trust key. We would generate it and we would name who we wanted to have, you know, access to with it. Okay. And then we would give them some type of password or name to it, right? Oops. There. Okay. That's set up that easily. Now, in regards to exporting it, that would be the export Docker Content Trust. Now, Content Trust, it provides a strong cryptographic guarantee over what code and what versions of software are being run in your infrastructure. So it integrates this tough framework into Docker using Notary, and that's an open source tool that provides trust over any content. And when we're pushing an image to a remote registry, our engine is going to sign the image locally with the publisher's private key, and this later pulls the image. Docker engine will use the publisher's public key to verify the image is exactly what the publisher created. So let's pull an image with Docker Content Trust real quick. So if I was just to pull this clock image, okay. It's a pretty quick situation there. And I'm going to temporarily disable Content Trust so I can successfully pull some unsigned content. Okay. And let's pull Hello World as well. Okay. Now, I want to enable Content Trust. How do I do this? That command I was telling you guys about and I showed you just a second ago. So if I was just to use this export Docker Content Trust command, it's that simple. Now, if I try to pull some unsigned content, we're going to get an error message. So let me clear this up to the top, right? Here we go. So I'm going to pull this clock image and we're going to see that it's going to say, no, I can't use that, right? It is unsigned. So we'd have to do a Docker login. And then we'd have to log in with our name right here. There we go. Okay. And then from there, what we would do is we would, since we have it enabled, we would push the image to our hub, right? So we would tag the image and then push it. me see here. So let's see if I can just get a list of my images, which is going to be very, very heavy. There we go. So I would use a Docker tag. I would use the clock image ID. So let me just pull this full thing, put that in there. And then I would use my Docker Hub username. And then name this clock latest. Now we would push it. So we would just push it with my username, right? And then we would reference that tag again. And it's going to ask us to go ahead and, if we don't already have this, it'll ask for basically a passphrase. Okay. So let's see here. Before we move on further, Bill, what's your take on content trust?
I'm going to scoop up security scanning in the same discussion, if you don't mind.
Go for it.
The way that I like to think about content trust and security scanning, and the way I like to encourage other people to adopt it, is as part of your continuous integration chain. Think about security scanning for a second. Amber already covered this, but what's it really doing? It's looking at your images and looking at all the binaries it finds in those images and checking them for vulnerabilities. Really, if you think about it, that's kind of like a unit test, right? Now it's a security unit test instead of a functionality unit test, but nevertheless, it's a validation step that we take on our images before sending them to production. It makes sense and is usually really smooth and easy to integrate that security scan step as part of your CI testing pipeline, right? So once your image goes off to testing for going through all its unit tests and going through all its integration tests, also have a step to do that security scan and validate that there's nothing you're going to regret sending to production in terms of known vulnerabilities in that image. Once you move through that continuous integration pipeline and get to the end of it, that's the place I think that content trust makes the most sense to add into your CI pipeline. So your image is past its security scan, it's past unit testing, it's past integration testing, it's validated and ready to go. All the different stakeholders at your organization are happy with this image and are ready to sign off on it. You can use content trust not just to secure the integrity of image downloads like it was originally designed for and like Amber described, but you can use it as like a rubber stamp to say, yes, this image has been approved. It has passed testing. It has been approved by ops. It has been approved by the security team. All the different stakeholders have signed off on this image and it's ready for production. That's actually how I see a lot of clients actually using content trust. So originally, like Amber and I both mentioned, content trust was envisioned as a way to prevent man-in-the-middle attacks from image downloads. But a lot of Docker Enterprise clients, I teach them about content trust and then they come to me and say, well, Bill, listen, my DTR is running inside my air-gapped data center that's buried in the desert somewhere that you can't even really prove exists, much less execute a man-in-the-middle attack against it. So why do I need to go to all this trouble with content trust? That rubber stamping ability, that ability to create a machine-readable, automatically enforceable gate on whether an image has been approved or not, is really where content trust shines, even in the most secure and unassailable environments.
Yes, absolutely. Okay. So when we're talking about signing images with content trust, with our Docker Cloud, we have the ability, as I was showing you guys, to push a container image and sign this with these keys that we generate. Okay. So I have included for you guys the steps so you can go through and practice it on your own, along with those links that I have at the bottom of this presentation or the end of this presentation. So the final key in all of this would be to use our delegation private key to sign our tag and push it to our registry, right? Okay. Now let's talk about our last piece here, and this is managing sensitive information. So now that we have access that is restricted, we have our images that are secure, it's time for us to manage our secrets. Now, two rules when it comes to managing sensitive information is that we don't want to bake it into our image, right? It's not difficult to find your unencrypted sensitive information in code repositories, logs, etc. And additionally, we don't want to use environment variables for our sensitive information. So anyone that could run a Docker inspec or exec into your container, they can find your secret. And the same is going to go for a user running as root. So let's talk about Docker volumes. They're the recommended way to access your sensitive information in the Docker documentation. And you can use volumes as a tempfs, a temporary file system held in memory. They remove the Docker inspect and the logging risk. However, root users can still see the secret as well as anyone else who can exec into your container. So a better option here would be Docker secrets. Secrets are encrypted. And if you need your secret in your running container and not just when building your image, you can use Docker Compose or you can use Kubernetes. Now let me show you guys just really quickly what that would look like, okay? Here we go. So say we're in here, let's go back to our manager. Well, we'll stay in one. Let me just clear it to the top, okay? Now with Docker Compose, I'm just going to go through and I'm going to make a YAML file real quick. Okay. And let me grab this from my notepad for time's sake, because I want us to be able to get to questions as well. So let's go up here. We're going to add in our services for this, right? And then we're setting up this situation where we're working with MySQL, right? We're setting up some WordPress. Let me go over to, let's see here. Secrets. There we go. Ah, that's where I need that space. Perfect. Okay. And then what I'm going to do is let me add in this last portion. Got my database password sitting right there, right? And then we're going to just add in our section on the secrets itself. Okay. So we've got our database, our volume, have all the information we need inside of our Docker Compose file, inside of our YAML. That's the point of this. So if I was to save this, and if we just used a Docker Compose up for just to build this image. There we go. Can see how simple it is, right? So with Compose, we have simply built the information that we had in that YAML file. It has our passwords in there, or our secret in there, right? And let me go back up here. So Bill, what is your opinion between volumes and secrets?
Use them carefully. Really, it's a question of hygiene, right? It's really easy when developing containers for the first time to say, oh, I'm just going to hard code my password in here and I'm not going to worry about it too much and I just want to move fast while I'm developing these containers. And that's how they get committed to GitHub. Right? This happens all the time. So please take the moment just to plan out how you're managing configurations with your containers. So when I think about secrets, I like to put them under the broader umbrella of config management, because that's effectively what secrets are, right? It's a type of config, it just happens to be a sensitive config. So when I'm designing a container, I like to think about what configuration am I going to provide on the swarm side with swarm config objects and swarm secrets, or there's really the exactly analogous object objects in Kubernetes, right? You got your config maps in Kubernetes and then your secrets in Kubernetes for insecure and secure information. That needs to be planned out not just for security hygiene, but for portability of your applications. When you start trying to put that application through your CI pipeline, if you've got hard-coded parameters in there, that's just going to give you a headache downstream, right? Part of this secret and config map provisioning functionality of both our orchestrators is to make it really easy to provide these configurations securely at runtime, right? Not at image build time, not during development, at runtime when these containers are deployed, so that that config and those secrets are appropriate for the environments that you're trying to deploy your containers to. That is a key element of portability for our containers. Another thing I'll point out here is that one thing I really push on people is to make sure that you aren't allowing anyone to connect directly, like by SSH, to any Docker engine running in your EE cluster. And what Amber just showed you here is a great example of why. If you can SSH into a box that has a container running with a secret mounted in it, if you're able to run Docker commands, you're able to extract that secret, right? You just exec into that container, and then that's securely sitting there mounted in plain text in the container using it. Obviously, we don't want this. That's why we always use UCP client bundles to restrict people's ability to do things like exec into containers and to allow them to operate the Docker system without SSHing into engine nodes and hitting that CLI directly. This, again, is exactly a concrete example of why I push people on that so much.
Yes, absolutely, absolutely. So these are all just, some great ways to secure your Docker content. There are plenty of other ways you can go about it, right? But the most important takeaway from all of this is security is never a set it and forget it kind of situation. It requires good hygiene and vigilance on our part to keep images and containers secure. So just a quick reminder on who we are. We are Stone Door Group. We're a Mirantis solutions integrator and professional Docker value-added reseller. We specialize in DevOps transformations, and we work with companies of all sizes to implement best practices using Docker and Kubernetes. So if you're here with us today because you're looking to take your Docker setup to the next level, we have a few items you might be interested in today. So we have this Docker CE to EE accelerator engagement that's available, and this service provides end-to-end solutions for migrating your applications to a secure production environment. So we take care of upgrading you to Docker Enterprise, migrating your applications. We provide the licensing needed, as well as consulting services to ensure that you successfully upgraded and have everything in place. So we get you where you want to be. The second item here is for a free 5-day trial of Docker EE, because don't you want to play around with this, right? This is available at our website on the link on the screen, or if you already have an instance up and running, use this command right here and you'll have access. Okay, that leaves us with a few minutes for some Q&A. So let's go ahead and get that started. Let me pull up some questions.
I'll start if you don't mind, Amber.
Absolutely, please.
There was a really great question from Jazz a little bit earlier. So Jazz asked, since SE Linux, Seccomp, and crypto algorithms based on FIPS are part of a modern host Linux kernel, what's the value add for Docker Enterprise? How is Docker Enterprise helping here? Given that all those features are actually part of the Linux kernel? This is a great question. And the thing that I like to remind people is that Docker invented none of these things, right? You're absolutely right. All those security features at the engine level are actually all part of the Linux kernel. And if you want to go ahead and start a process and impose half a dozen different kernel namespaces on it, and apply an SE Linux profile, and apply some root privilege management constraints on it, you can do that. There's great blog posts out there about how you can apply the security features of a container to an uncontainerized process, basically making containers by hand. It's difficult, tedious, and takes forever, as opposed to just typing Docker container run, which will impose all those features on top of your processes for you, right? The idea here is not that it's new and different, but it's democratized, right? It takes all of those security features and deploys them automatically for you.
Great, good question. Let's see here. We have another one about security features being enabled, the ones that I mentioned at the beginning, FIPS, SE Linux, Seccomp, should they all be enabled on the host? And yes, FIPS is more though if your environment is going to need it. And it's required by governments generally, well, everything I've run across.
Yep.
So, okay, let's see here.
I mean, if you don't have things like Linux security modules and secure computing mode enabled for your containers, you got to start asking yourself, well, what is a container at that point, right? All a container really is a process with these constraints applied to them. And if you take away secure computing mode and like Linux security modules, you've taken away a lot of what makes a container a container. I guess you still have kernel namespaces. That's pretty important. But you've lost a lot of what makes a process so isolated in a container.
Exactly. Let's see here. Massimo has a question. Is it already possible, or is there a roadmap to retag images directly in the registry?
Yeah, absolutely. That's called an image promotion. So if you have a look inside DTR, click on into any repository you have. Amber, if you have one, can you pull up your DTR if that's not too inconvenient?
Yeah.
So if you have a look, just go to any old repository, doesn't matter which one, and look at promotions right there. So let's go ahead and click on that. Now, what a promotion is going to do is it's going to do exactly what you just asked. It's going to take an image and then retag it effectively as another image. Now, you can do that manually, just anytime you want, or you can do what Amber is showing you here and create some rules for when this will happen automatically.
Yep.
And so really, I mean, we give it this fancy name, we call it image promotions, but honestly, it's really just retagging images, right? Giving them a different name and a different tag.
That's all we do. So we would select what we wanted to put in there, that criteria. We would select the target repository and then the variables for that tag name. Good question. Okay, let's see here. Let me go ahead and go forward since we have the majority of our questions answered here. And there you go.
Excellent. Thank you, Amber. So if you enjoyed Amber's session today and would like to dive deeper into learning about Docker Enterprise and Kubernetes, Mirantis offers a wide palette of different courses where we'll take you on a 2 to 5 day intensive discussion of all these technologies with your hands on the keyboard. So today we mostly just gave you a brief little lecture and demo about these concepts. If you want to try this stuff yourself with Amber or another expert Stone Door Group instructor leading and guiding you through this content, you can do that in one of our workshops. So all of our workshops are based on the real world experience of our field team. It's gone out to customers just like you, help them get started with Docker Enterprise, help them get started with Kubernetes and containers, and brought that learning back to us that we were able to turn into these workshops. That really my goal with the workshops that we create and deliver is to accelerate your adoption of these technologies. Let's make it take just a few days and weeks to get started with Kubernetes and Docker Enterprise rather than months and years like it does in an unguided situation. Give me the next slide here. If you're interested in Docker training, we've got this series of Docker Enterprise trainings available to you. It'll take you all the way from fundamentals, that's your first encounter with containerization, through our developers and operations tracks, where you'll learn all the different features of the Docker Enterprise platform, how to leverage them in operational and development and DevOps type scenarios. If you are more interested in vendor agnostic Kubernetes training, let's have a look at the next slide. We also offer a rich series of Kubernetes classes that'll take you, again, on that same learning journey from your first encounter with containers and Kubernetes all the way to advanced production grade deployments of kube clusters at the end of your CI and CD chains for your containers.
All right, great. Well, thanks, Bill and Amber. Another great session. And I just want to give a quick shout out to all of those. Quick congratulations to our prize winners from our previous events. You guys will receive a Stone Door Group Silly Pint. If you have not received it already, you should be getting it in the mail shortly. And then thanks again, you guys, for attending today's presentation on Docker tips for better security. As mentioned earlier, we will be hosting our final event of this series on May 14th, covering Kubernetes tips for better productivity. Again, just like today, it'll be 1 hour starting at 9 a.m. PST. Following today's presentation, you will receive an email providing a link to today's recorded session and materials. And at the close of today's event, you're going to see a survey poll, and we ask that you take a minute to answer 4 brief questions to help us improve our future presentations. Thanks again to our presenters, Bill and Amber, as well as our participants for taking the time to join us. And again, please feel free to reach out to us at letsdothis@stonedoorgroup.com. Thanks again, and I hope everybody has a great day.